Hello learners, welcome back to Constant Learners. In today's video, we are going to do one of the most important topics in the syllabus of database management system, and that is data models. But before we begin, I'd like to thank you for such an amazing response that you've shown to my channel. Data models was one of the first videos, one of the first topics that I posted on my channel. But after posting 3-4 videos, I was so demotivated with all the hard work that was required to be done to post a video, and I was not used to it, so I stopped. But the overwhelming response that I received on this video was amazing. So thank you so much for all your love, all your support, and I hope it continues in the future as well. All right, let's get started. Today in this video, we are going to discuss what data models are. Then we are going to see why data models are important. Why do we need them, right? Then we are going to do the phases of data modeling. And finally, we will head to the most important part, which is going to take the maximum time, that is data models. All right, let's start quickly with what data models are. So data model is kind of a flow chart, all right, that illustrates entities, their attributes, and relationship between the entities. All right. Now we know that data are raw facts, right? And this data needs to be stored somewhere. Where do we store this data? Inside the database, right? Now database is not just a location where we take our data and dump, right? The database has to have a proper structure. There needs to be a proper arrangement, a proper logical structure where the data can be stored systematically, right? So data models define the logical structure of the database. All right. It's the job of data models to define the logical structure of the database. Now, to store the data inside the database, the user will need some kind of interface, right? Or if we have to read the data from the database, we will need some kind of interface. We have taken ample amount of examples in the previous videos. Please, if you don't understand how this entire process of database works or what is a database, please watch my previous videos. The concepts will get clarified very, very clearly. Okay. Now, database management system provides us that software, or it provides us that interface, right? Where we can communicate with the database, whether we want to store the data, whether we want to read some kind of data or modify some kind of data, all of that we can do through database management system, right? So in short, we can say that the entire process of storing or managing the data inside the database is performed through database management system, right? And it is the job of data models to define how this entire process will take place. Also, we know that data inside the data models should be connected or related to one another. And data models take care of this important aspect as well. Let's discuss why exactly do we need the data models, right? Now, we know that the database design process is not easy, right? As once the database has been designed and the data, we've started storing the data inside the database, this database design cannot be changed every now and then. We can make a few modifications, but we cannot change the entire database or the entire structure of the database, right? So there are certain aspects that we need to consider before we design a perfect database, right? And data models help us to take care of these aspects so that we can have a perfect database. Let's discuss what are these aspects that we need to consider before designing a database, right? So first things first, we need to study the data properly. When we are designing a database for a particular business or for a project, we need to identify the business. We need to identify the project. We need to study their data in detail, right? And data models help us to identify or understand the data about different business processes, right? Next, we studied data abstraction in a previous video. What is data abstraction? The user is able to access the data at any time, but he is unaware of the technicalities or the complexities. What is happening behind the screen, right? How the data is being stored or how the data is being managed inside the database. The user does not know that. He just opens an app or he just goes to a particular website, tries to access the data, tries to access the database, and then his job is done. He does not know what is happening behind the scenes. That is data abstraction. And data models allow us to achieve data abstraction, right? Then another important aspect of a good database design is prevention of repetitive or redundant data, right? We cannot have repetitive data inside our database. So data models take care of that as well, right? And some data models provide us a visual representation of the data, which in turn helps us to understand the data requirements more easily, right? And thus it makes easier the designing of databases. All right. I hope that this basic concept of what data models are and why do we need them is clear, right? Next, let's discuss what are the phases of data modeling. As I said, before designing a database, we need to identify certain aspects of the database, and data models help us to do so. Like, for example, first, before we begin a database design process, we need to understand or visualize the project or the company's business processes and its workflow. Like before designing a building, what do? We first plan, we discuss our requirements, right? And then we talk to the engineers, and then the engineer draws a plan, and finally the construction begins. So first we need to identify the requirements of the business, like what kind of database would they need, right? And this planning or this identification process is known as a conceptual model. Okay, once the conceptual model is done and we have understood the concept of a particular business, we move to the logical parts, right? Logical parts means what? That includes identifying the data entities, their attributes, and the relationship between the entities. And this is known as the logical model, right? And after the logical model is done, finally, a technical structure is built to store and manage the data, which is known as the physical model, right? So this was some basic around data models. Now let's head to the important part, that is the types of data models, right? So we're going to discuss 5 main types of data models: hierarchical model, network model, relational model, entity relationship model, and object oriented data model. Then there's float model also, there's semi-structured data model also, but we're not going to get into those details. All right. Let's start with the hierarchical data modeling. When the data is arranged in the form of levels or classes or grades, that is in the form of a tree-like structure, that is data is organized in the form of a tree-like structure, which looks something like this. Okay, so this is known as a hierarchical data model. Here, the higher layer, like this is the higher layer. This is perceived as the parent, right? And the segment that is immediately beneath it, that is this one as well as this one, these are considered as the child records, right? So this is the higher layer for these two children. If these are considered as the children, then this will be considered as the parent, right? So the higher layer is perceived as the parent, while the segment that is immediately beneath it is considered as the child records. All right. Now hierarchy starts at the root node. All right. So this is the root node. Hierarchy starts at the root node. So at the top is the root node, which extends towards the child nodes, right? So these two are children for this parent here, correct? But each child will only have one parent. Now this parent is having two children, 1 and 2. But if you look at this child, it is having only one parent. If you look at this child here, he is having only one parent. If you look at this one as the parent, then it has again two children. But here, this child has only one parent. This child has only one parent, right? So every parent here can have one or more than one children. But every child will have only one parent, right? So as we can see, one-to-one relationship can be established. That is, one parent can have one child. So one-to-one relationship can be established. And one-to-many relationship can also be established, because one parent can have more than one children also, right? So one-to-many relationship is also being established, right? But do you see any many-to-one relationships? That is, two parents having only one child. Is it possible here? This is known as many-to-one relationship. Can we see any many-to-one relationships here? No, right? And do we see any many-to-many relationships also? That is, two parents are having more than two children, right? That is, this child is having two parents, this child is having two parents, and both of these parents are having two children. No. Many-to-many relationship also cannot be established in hierarchical data model. Only one-to-one and one-to-many relationship is established here, right? Since this model only allowed a one-way approach, this is not used much these days. A simple example that we could take is of a college, all right? Let's say this is the college, this is the root node, okay? Now college has two children. One is the students and the other one is the faculty, right? Then students can have more parts, IT, then CS, then let's say electronics engineering. Faculty can also have multiple parts, let's say admin, correct? Then professors, then assistant professors, right? So this can be an example of hierarchical data modeling. Every parent is having more than one children, but every child is having only one parent. All right. I hope that hierarchical data model was clear. Now, next is the network model. Now, network model expanded from the hierarchical model. Why expanded from the hierarchical model? Because it is quite similar to the hierarchical model, but it is able to overcome the disadvantages that we faced in the hierarchical model. What were the disadvantages in the hierarchical model? In hierarchical model, one parent could have more than one children, right? This is child 1, this is child 2. So this one parent is having two children, right? But one child could not have more than one parent. So one to one relationship was established, one to many relationship was also established. But many to one, that is many to one relationship could not be established, and many to many relationship could also not be established. So these disadvantages are overcome in the network model. In network model, what is happening? As you can see here, this is parent 1, right? This is child 1, this is child 2. So if you look at this parent is parent to this child as well as this child. So one parent is having two children, right? Then if you look at this child here, so this child is having this as one parent and this as the second parent. So one parent is having multiple children as well as one child is having multiple parents, right? So we can say that this model is representing or exhibiting more complex relationships, right? Because one parent is having more than one children and every child or some children can also have multiple parents, right? So this improves the database performance because there is no one-way approach. The data is far more related to one another. Here, the data is far more related to one another because in hierarchical model, the connections were very minimum. But here, the data is more connected to each other, right? Also here, the data is organized using two fundamental concepts known as the records and sets. Now, what are records? Records are nothing but the fields. So this is a record. This is a record. This is also a record. This is also a record. So these are records. And what are sets? Sets define the relationship between the record. So we can say that this is a set because it is connecting these two records. This is also a set. This is also a set. So all of these connections are nothing but sets because they are connecting the records. All right. This parent is having this one as its child. This parent is also having this record as its child. And this parent is also having this record as its child, right? So a child is having multiple parents here. So one to many relationship is being established. One to one relationship can also be established. Many to one relationship is also being established, right? And many to many relationship is also being established. How many to many? Like if you look at this parent here, this is the parent to this record also, it's going here also, and it's going here also, right? This one, it's going here also, and it's going here also. So many to many relationship is also being established. All right. So network model, we can say that it is more advanced or it is more successful compared to the hierarchical data model. All right. Now let's head to one of the most important data models, which is relational data model. So relational model is one of the most widely used data models. Here, the data is stored in a two-dimensional table consisting of rows and columns, right? And these tables are known as relations. And one of the most important aspect of these relations is that the data inside these relations is interrelated to one another. Now, what is a relation or what is a two-dimensional table? A table consisting of rows and columns. So this is a two-dimensional table. So all the data in these rows and columns is supposed to be interrelated to one another, right? That is why the name of this database is relational database. All right. So the database that is based on this kind of modeling is known as relational database. All right. And the model is known as relational data model. Here, the data storage is extremely sophisticated. It is very disciplined. As you can see, everything is in its position, right? All the data is stored in its position. We cannot store any random data anywhere. If this column is supposed to take the name, this is only going to take the name. And also, since the data storage is so sophisticated, the accessing of data is also very easy. All right. Now, as we discussed, the database here is called relational database, right? So we know that when we have to store or retrieve the data from the database. So this is a user. He will have to either store the data inside the database or update the data into the database or retrieve some kind of data from the database. And how does he perform all of these tasks? Through database management system, correct? So these relational databases, they use a special database management system known as the Relational Database Management System, known as RDBMS. All right. So relational databases are the databases used for this kind of modeling, and relational database management system is used as an interface to store, update, delete, or retrieve the data from the relational databases. All right. Now, to store the data in the relational databases, we use structured query language, that is SQL. SQL is a programming language that we use to communicate with the relational databases. For example, this is a user and this is the relational database, right? Now, to communicate with this database, the user is going to use the relational database management system. But how exactly are we going to do that? We are going to use the structured query language. This is a programming language. So we write some kind of queries in structured query language, and these queries perform whatever task that we are requesting it to perform, right? Now, every user is not going to know structured query language, right? If I talk about Google, if I need some kind of information from Google, I'm just going to write my requirement in the search bar in my own language, in English language, and the Google is going to retrieve my request and fetch me the data, right? I do not need to write a query in structured query language to retrieve the data from Google's or whatever database, right? Now, structured query language uses the declarative method for specifying data and queries. What is a declarative method? The user is unaware of the computational logic of the programming and of the workflow, right? I am just putting my request here and I'm getting the data that I need. I don't know what is happening in the background. I don't know what is the sequence of events that are being performed. So this is known as declarative method for specifying data and queries, right? It focuses more on getting the job done rather than how the job is getting done. So the user is not getting into how and why of the databases, right? He just enters his requirement. His requirement turns into an SQL query, and that SQL query performs the task of fetching the data from the database. All right. Now let's discuss the components of the relational model. Okay. The relational model, as we discussed, is nothing but a two-dimensional table called as the relation. All right. Now these relations store the data about a real-world entity. What is an entity? Entity is a topic or a place or a person or an organization or an event about which we are storing the data inside the database. One particular relation will have data about one particular entity. For example, student underscore info. So this table, this relation here is about the student information. So this will only have information about the student. Then this relation has rows. Now these rows are called as tuples. All right. And these rows represent a single record. That means this particular row is going to store data about one particular entry. Like if this is a student table, then this row, this entire row here is going to store data about one student only. So in each row, we are storing data about one particular entry. Also, no two rows can have data about the same student. That means there cannot be any repetitive or redundant data. If we try to store the data about same student twice, we will get an error message that this student already exists. Like if this row is about a student named Sachin, then it will have Sachin's age, Sachin's address, Sachin's phone number. Everything about Sachin will be stored in one particular row. Then next we have the columns. So these are the columns. This entire structure is a column. This is a column. This is a column. And these columns are called attributes. Attributes represent the properties or the characteristics of this particular entity, right? For example, here we are going to store the name. So this entire column will have only the names of the students, okay? Names of different students. This entire column will have the age. So this entire column is going to store age of each student. Then if this column is about the address, right? Then this entire column will store only the address of each of these students. It's not going to accept any other values. We program the databases in such a way that it will not accommodate any other values. That means age column will not accommodate the name or the address. Address column will not accommodate the age. All right. So we design the database in such a way that only the appropriate values are accommodated in each column. All right. How does that happen? With the help of domains and constraints. What are domains? Domains and constraints are some kind of restrictions that we put on each of these attributes or each of these columns, right? Domain specifies the acceptable values that a particular column is going to accept, right? And what are those acceptable values? For example, if this is the name, then name will only accommodate the alphabets from A to Z. So we are going to declare that this column is going to have only characters, right? If this is the age, right? Then we are going to declare that this is only going to be integers because it can accommodate only numbers. If this is an address, right? So address will have both integers as well as characters because there can be number also, apartment number or house number along with the address. So it's going to accommodate both address and integers. So this is done by the domains. Here what are we doing? We are specifying the data type that will be accommodated in each of these columns, right? Then constraints are the limitations. Constraints are the limitations that we impose on each of these attributes or columns. What kind of limitations? Like this is the name, right? So we can impose that name cannot have more than 20 characters. Address, we can declare that address could be 100 characters long. Now age, the age of a student is not going to be more than 2 integers. It's going to be a 2-digit number. So we can declare that the length of age column is only going to be 2 integers. So this is nothing but the limitation. Then we can declare that the name column cannot be null. Let's say we declare it to be the primary key. Okay. So primary key cannot be null. And even if it is not a primary key, we can declare any attribute to be not null. This is nothing but the constraints. Constraints are the limitations that we are imposing on each column. Okay. And these domains and constraints are for columns. All right. These are not for rows. We define or specify the domains and constraints for each column, not for the rows. Because rows are going to have different values. Name will have 20 characters. Age will have 2 integers. Now, most of these characteristics will also be visible in the entity relationship model. I hope that this was very, very clear to all of you. Now, let's head to the entity relationship model. This we are going to do very quickly because we've already understood what is entity, what is attributes, what are domains and constraints. We've understood all the basics of relational model very well. All right. Now, entity relationship model allows us to visualize the data, that is, the entities and their relationships. Okay. The entities here are also entirely based on the real world entities. Real world entities, as we discussed, are nothing but something that is physically present. Now, the most important difference between relational model and entity relationship model is in relational model, every relation is about one single entity. Relation means what? The table, right? So, one table is about one entity. All right. So, every relation is about one entity. However, entity relationship model defines the relationship among different entities, right? So, here we are trying to identify the relationship between more than one entities. Entity relationship model helps us to examine the structures graphically. That is, we have a pictorial representation of the entities and their relationships. So we can understand the relationships far more better, right? The database designers prefer to use graphical model or graphical tools, right? That can help us to identify the entities and their relationships. Now, entity relationship model complements the relational model. As I told you, most of the characteristics, in fact, all of the characteristics or all of the components of the relational model are also present in the entity relationship model, right? So, both of these models, they complement each other, right? When we have relational model as well as entity relationship model combined together, we get a very strong structured database design. Now let's quickly discuss the components of entity relationship model. We are not going to get into a lot of details. First one is the entity, right? We know entity is something about which the data has to be stored. It is similar to the relational model. But in case of entity relationship model, the entity is represented inside rectangles. Okay. For example, student underscore data. This is an entity represented inside a rectangle. Then the properties of the entities, or we can say the characteristics of the entities, are defined by the attributes. Just like in the relational model, attributes define the characteristics or properties of an entity, right? But in case of entity relationship model, the attributes are defined inside the oval. Just like here, student ID, name, age. What are these? These are the attributes of which entity? Attributes of entity student underscore data, right? Then again, just like relational model, these attributes have some characteristics defined by domains and constraints, right? Domains define the data types and constraints define the limitations. All right. We do not need any kind of geometrical structure for this because these are expressed with the attributes, right? These go with the attributes. Then comes the relationship between the entities. The relationships are defined inside a rhombus. All right. So when you see anything inside a rhombus in an entity relationship model, understand that it is the relationship between the two entities, right? And all of these entities, attributes, and relationships are linked with each other using straight lines. All right. We connect them using straight lines. Now let's quickly take an example of how relational model and entity relationship model complement each other. So we are going to take one example and we are going to draw both the models, the relational model as well as the entity relationship model, right? So here we have two entities. Entity one is student underscore data. Entity two is professor underscore data. That's prof underscore data, right? These are the attributes of the student data entity. What are the attributes? Student underscore ID, name, age, course ID, right? So all of these attributes or all of these columns are explaining something about our entity. It is giving us some information, right? Then prof underscore ID, name, age, course underscore ID. These are giving us some information about the professor, right? And these are the attributes of the professor's data. Now, if you see clearly this course ID and this course ID, we see a common column between the students and the professor's table. So we can say that we are linking or we are connecting or we are relating because the data inside every database. See, this is a college database. College database has all the information about all the functionings or all the operations or all the people that are related to the college, right? And both of these entities or both of these tables are a part of the same college database, right? So this column course ID and this column course ID, these are the same columns, all right? Let's say this student here, student 1, whose name is something, let's say Rahul, all right? Let's say he has he is a student of CS and course ID of CS is 001, right? So here he will have 001. Let's say second student, Sachin, all right? He belongs to IT, all right? And his course ID is 008. So here we will have 008. Let's say third student, whoever, he is also from CS, so his course ID will also be 001, all right? Then let's say here we have the professor ID, 11, 12, and 13. This professor, let's say, is teaching IT. So again, the course ID will be 008 because IT's course ID is 008. Let's say this professor is teaching computer science. So his course ID will be 001. Let's say this professor is also teaching computer science. So his ID will also be 001. So this course ID column and this course ID column is the same. All right. It's having the same values but for respective people. All right. So we can say that these two entities are connected to each other through this course ID. All right. Now let's discuss the same example with the entity relationship model. All right. So we know that in entity relationship model, we represent the entities inside the rectangle. So this is our entity 1, student underscore data. This is our entity 2, prof underscore data, because that is the data about the professors, right? Then we have the attributes represented inside the ovals, because we know that in entity relationship model, the attributes are represented inside the oval. Here we have student ID, name, age, and course ID. Again here we have the professor ID, name, age, and again the course ID, right? Now how is the student entity related to the professor entity? These professors are teaching these students, right? So we can define the relationship as teachers, all right? So how are we linking these two entities? The professors in this table are teaching the students in this table, okay? So this table has the information about the professors that are teaching the details, the students whose information is in this particular entity, right? These entities are related or connected to the attributes also through a straight line, right? So everything in entity relationship model is connected with a straight line, and these straight lines are known as links, all right? So everything is interrelated or linked with each other. So as we saw in relational model, every table was about one single entity. However, entity relationship model explains the relationship between different entities. Now let's quickly head to the object-oriented data model. Object-oriented, I'm sure you must have heard about the object-oriented programming languages, right? So this is a combination of object-oriented programming language and object-oriented data models. These were created or developed to represent complex real-world problems. Now, its approach is very similar to entity relationship model in terms of how it represents the entities, attributes, and relationships. Okay. However, here both data, or we can say entities, and their relationships are contained inside a single structure, and this structure is known as an object. All right. Have you studied any object-oriented programming language, or do you know the concept of an object-oriented programming language? In object-oriented programming language, what happens is we have some objects. Okay. Like usually we take example of cars. Okay. So there are multiple different cars. Let's take first one as Toyota. The brand is Toyota. Okay. Second brand, let's take as BMW. Correct. And third one, let's take as Suzuki. So these are the brands of the cars, right? Now, all of these cars are going to have some kind of color, right? And some kind of model, right? So the attributes for Toyota are going to be color and model. All three of these are objects, right? Because these are objects, these are cars. But all of these objects, these are having similar attributes, right? So we can say that the objects with similar attributes can be accommodated into a single class. Okay, these can be accommodated into a single class of cars. And this class is also going to have some attributes. Object-oriented data models are a combination of object-oriented programming languages and the relational database model. What is a relational data model? Something that has entities, something that has attributes, Then there is relationship between the entities. So we have to include all of these along with the components of the object-oriented programming model. That is the objects, the class. Then there are methods also. If you've studied the object-oriented programming language, you must have studied the methods also. So we have to combine all of these components of both of these things and come up with a data model known as the object-oriented data model. All right. Let's quickly discuss the components of object-oriented data model. As we discussed, objects are a combination of entity and their relationships, right? These two combined together can be called as the objects, right? Objects are the abstraction of real-world entities and their relationships, right? Now, objects contain the data and code because it is a combination of a programming language and the data, right? So it contains both, but both of these are hidden from the user, and thus it provides data abstraction. And initially, when we started the video, we saw that data abstraction is an important aspect of data models. All right. Now, these objects have different attributes also. Just like in relational model and entity relationship model, the entities had different attributes, right? Explaining the properties of the entities. Similarly, here, objects also have different attributes. Different objects have different attributes. Attributes are nothing but the properties of the objects. Just like in relational model, they were the properties of the entities. Then we have the methods. Methods define the behavior of an object. That is, what operation do we want the object to perform. Like in entities, we only had attributes. That is the properties. Objects don't just have attributes. They have attributes as well as the methods. They have to perform some kind of action or some kind of task. All right. So methods are the real world tasks that we want the objects to perform. Then we have a class. We've already discussed class is the collection of similar objects, right? So this is a box of chocolates, and inside this box we have some assorted chocolates, right, from different brands. So this entire box of chocolates is going to be the class because the properties of the chocolates are going to stay the same. However, here we will have different brands of chocolates, right? And all of these brands or all of these chocolates are going to have similar attributes and similar methods, right? So the objects that have similar attributes and similar methods can be accommodated into a single class. All right. Then in object-oriented programming languages, we study the concept of inheritance also, right? Wherein a new class or a child class can inherit the properties of the parent class or the base class. That is also available in object-oriented data model. All right. Let's quickly take an example of object-oriented data model. See, here this student info is an object. All right. This is object 1, let's say, and professor info is object 2, right? There we had entities. Here we have objects. Then these student ID, gender, age, and course ID. These are nothing but the attributes similar to the entities because objects also have attributes. All right. So these are the attributes. But along with attributes, we discussed that objects also have methods. Objects do not just have attributes, they also have methods. So here, what action do we want our object to perform? To get the marks of each student. Here, we are also asking for the course of each student. So some kind of action is being performed. We want our object to perform some kind of task. All right. So it has methods, get marks and get course. And here the method is get info. All right. Now, both of these, the students as well as the professors, these are belonging to the same college. All right. So we can have a class. I know this sounds very silly, but we are having a class of college underscore people. And both the students as well as the professors are the people who are connected to the college. So they can be part of the class college underscore people. And the attributes of this class are name, department, and mobile number. So both the students as well as the professors are going to have some name. They are going to have some department. They're going to have a mobile number. All right. I hope that object-oriented data model was also clear. The explanation was clear. If you like the explanation, please let me know through your likes, through the comments, whether positive or negative. Let me know your feedback. I will understand whether my videos are helping you or not. All right. And if it did help you, please give it a thumbs up. Share your thoughts about the video in the comment section. If you have any doubts, any queries, you can write that also in the comment section, and I make sure to respond to each and every comment that I receive. All right. Thank you so much for watching the video. Please subscribe and share this video with as many people as you can. Thank you for watching.